Welcome everyone. In this video lecture, we will solve a MOSFET circuit problem from Microelectronics Circuits book, problem number 17. So the question is, an enhancement type NMOS transistor with threshold voltage VT 0.7 volt conducts a current ID drain current of 100 microampere when VGS equals to VDS 1.2 volt. Okay, it is given. So find the value of the drain current ID for VGS 1.5 volt and VDS 3 volt. Also, calculate the value of drain to source resistance, that is our RDS, for a small value of VDS and VGS 3.2 volt. So first of all, we have to write the given thing. Okay. So in the given thing, it is given VT value is 0.74. Okay, which conducts a current ID is given 100 microampere. Okay, for VGS equals to VDS 1.2 volt, it is given. Okay, here it is given VD 0.7, ID 100 microampere. Okay, so we have to find the value of ID. So we have to find the value of ID, drain current. Okay, for VGS 1.5 volt and VDS is also given 3 volt. Okay, so these two things are, we have to find ID, and in the next page we have to find the value of RDS. Okay, we have to find the RDS for a small value of, for a small value of VDS and VGS equals to 3.2 volt. Okay, so these are the thing we have to find ID and RDS. ID for 1.5 volt and VDS 3 volt. Okay, so in the question, first we have to identify in which region the circuit is operating. Okay, so first of all I want to just draw, suppose there is a, okay, NMOS is there, gate is there, drain is there, source is there. Okay, in the first case everything is given. Okay, and in the second case we have to find ID, but we don't know the transconductance parameter, the process transconductance parameter, so that we have to find. Okay, but before that, once again I am just drawing the very fundamental ID in milliampere range and say VDS in volt range characteristics. Okay, this characteristic is also very important. Okay, and this one I am saying, this one is our VGS minus V2. Okay, this side it is in the saturation region. In every problem I am just writing or drawing this diagram linear region. Okay, so the very first case, for this case, okay, for this case, first we have to identify, for this saturation region, the VDS should be greater than equals to VGS minus VT. Okay, for the linear region, VDS should be less than VGS minus VT, that we have to know. Okay, so now in this case find VDS. What is VDS? It's simply 1.2 volt. So I'm writing 1.2 volt, and find VGS minus VT. Okay, so VGS is also same as that of VDS, so 1.2 minus 0.7 volt. So 0.7 and 1.2, so it should be 0.5. So here we can clearly say that the VDS value is greater than VGS minus VT. So device is in the saturation region. So first we have to identify device is in this region. Okay. So now next we have to find the, using this one we can find the K and S. Okay. K and S we have to find, because K and S is not known to us. Okay. So first we have to write the drain current equation in for the saturation region. So I am writing like this: saturation 1 by 2 mu n cox W by L VGS minus VT whole square. Simple. Okay. Now everything is given. So now ID in saturation is there. From this one we can say this one is 100 microampere. So we can write like this: minus 6. Okay. 1 by 2. and I am writing the whole term, this whole term. Okay, okay, this whole term as a kn. Okay, I am writing this as a kn, and this one is vgs minus vt, because this kn is not known to us. Okay, so better to use like 1 by 2 kn, and vgs, in this case vgs is vgs minus vt already find, so we can write directly 0 0.5 whole square. Okay, so from this side we can easily say the kn. Okay, that is simply our mu n co x w by l, process transconductance parameter value will be 2 into 100 into 10 to the power minus 6. Okay, divided by zero point 0.5 into zero point 0.5, we can write like this. Okay, or we can write, if we solve this one, we can write like 10 to the power minus 4, then if we remove this decimal, so 10 into 10, so 10 square. Okay, so we can write 100 by 25. Okay, then it should be 4. So k and dash will be 8 into 10 to the power minus 4, and unit will be what? Ampere per volt square. Okay, so this one is the very first thing that we have to find, because we have to find the value of id. So for id we need the kn, the process transconductance parameter, so we have already find. So now we have to find the value of id, this. Okay, we have to find this id. Okay, so now for this id calculation, first we have to again examine, is it in the saturation or linear region. Okay, so here the vgs is 1.5, vds is this. Okay, so here the vds value is 3 volt and vgs is 1.5, vgs is 1.5 volt. So we have to think about vgs minus vt. So vgs is 1.5 minus 0.7, so it is simply our 0.8. Okay, so again here the vds value is greater than vgs minus v2, so it means the device is in the saturation region. Okay, so device is in the saturation region. So then after what we will do, vds is this, so again we have to write the drain current equation. Okay, id value in saturation, so it should be 1 by 2 mu n cox w by l vgs minus vt whole square. Simply we can write this should be 1 by 2 mu n cox w by l, we have already known to us, that is our this one, 8 into 10 to the power minus 4 into vgs minus vt value is now 0.8. So what we can write, 0.8 into 0.8. Now we have to solve, so make it 100. Okay, then it should be 4, then 32 into 8 into 10 to the power minus 4. So if we solve this one, what should be the value? 256. 256. Okay, and there is also 100 is there. So if this 100 will go up, so 10 to the power minus 4 into 10 to the power minus 2. Okay, so simply we can say this id value will be 256 into 10 to the power minus 6, or simply 256 ampere. So the value of this id is just 256, 256 microampere. Very simple. But first we have to find the this transconductance parameter, which is this one. So we have to put this value mu n cox. Okay, and after simplification, but we have to just find the in which region the circuit is operating. Okay, so this one is the graph. Okay, so this was the first part. Now we have to find the rds value. RDS value for a small value of VDS. So for a small value of VDS, we can say it is somehow in this range or anywhere for a small value of VDS. So for a small value of VDS, the device will be in, for a small value of VDS. Device must be in linear region. Okay, for a small value of VDS, so VDS should be less than VGS, so it should be in the this region. Okay, linear region. So we know the formula for drain current in the linear region. What we can write? Simply mu n cox w by L VGS minus VT into VDS. These are the very important formula that we have to remember. Okay, so now then after this one is the linear one. Okay, for a small value of VDS, for a small value of VDS, you just remove VDS square by 2 to almost 0. So we can make it 0. So for a small value of VDS, we can write the ID. I am not directly writing mu n cox w by L VGS minus VT into VDS. Okay. So now the RDS value, RDS, drain to source resistance, a small drain to source resistance, RDS, that is our VDS by ID. Okay, so VDS by ID is simply 1 by mu n cox w by L into VGS minus VT. Okay, so one can simply write 1 divided by this one mu n cox w by L we have already calculated, that is our 8 into 10 to the power 4. So simply we have 8 into 10 to the power minus 4. Now VGS for this problem, what we have to use for this one, VGS is 3.2 volt. For this problem we have to take VGS is given 3.2 volt, already mentioned in the question. Okay, once again you can see VGS is 1.2 volt. Okay, so 3.2 volt, sorry, 3.2 volt. So we can write as 3.2 minus VT 0. Simply 7. Okay, so what we can write, 1 by 8 into 10 to the power minus 4. Now 3.2 minus 3 to the power, it should be 2.5. Okay, now we have to solve. So 1 by 8 into 10 to the power 4 by 25, and this 10. I am just removing this point here, so I can multiply with 10. Okay, so one can write 10 to the power 5 by 200. Okay, or one can write this as a 100. Okay, or we can simply write 1 2 3 4 5 just for the calculation purpose. 00 should be 2 2 5, so it should be 500. Simple, you can do the calculation. Okay, so RDS value will be simply 500 ohm for this VGS 3.2, and the formula is like this. So RDS value, using this formula we can say this one is 500 ohm. So okay, so this is all about this question. This one is a simple question, but we have to very careful about the basic. Okay, so this is all about this question. So just I am writing the this value, RDS value is coming. Okay, okay, I am saying 500 ohm, and this ID is coming around 256 micro. So 256. Okay, so this is all about this question. So thank you for watching this video.